right. Good morning, my fellow devs. My name is Elisha, and today we'll be talking about retrieval augmented generation and how we can utilize our RAG systems to accelerate medical insight. And yeah, so my name is Elisha Bere. I'm a software developer, been writing code for the past 7 years, mainly TypeScript, Python, and Solidity. And I'm just passionate about just making applications that might have real world impact, mostly for communities. And I believe this one, some people might take it and apply it in real world scenarios and all those things. So that's the AI version of me. I think it did a really good job. So, yeah, one thing that was interesting for me to actually do this talk was because I was having a chat with this other doctor friend of mine, and he told me he spends almost like two-thirds of his time just doing research. And in my mind, this was way back where REG wasn't that big. There were solutions around to actually solve this problem, this research problem, or give the doctors access to information or have them have this information at the tip of their hands. So the whole idea is like, okay, how about we give you your time back and try to find a solution? And that's where REG came into play. So what are RAG systems? This is just a technique where we are searching for relevant information in a vast database of information, and our RAG systems are able to go and pick the most relevant information, pass it to our LLMs, and then text is then generated in a readable or understandable manner by human beings, which is our text. So we take the relevant information, pass it into LLM, we get a response. That's nice. I think we've all worked around with AI and we've seen how good it can get when it comes to that. So the importance of REG in healthcare is so that we have a lot of information out there from universities, we have a lot of information from their schools, but who has the time to go back to your study books or your textbooks to just go and find out information about a specific condition? And that's where RAG comes into play, where we can just have a database of petabytes of data, and RAG will be able to go and select the relevant information within that data and give it back to the user, which will cut down the research time for the doctor. So basically, that's why we are using RAG in this regard. So we are going to be looking at a tool called LangChain. LangChain is a framework just designed for to help developers use. So LangChain helps developers build AI or RAG systems that will help them. So the LLMs will be reasoning, generation of data, and with LangChain, it enables us to add a bunch of tools around our LLM, which is something that we did not have because our pre-trained models that we have out there have limited information. It can't get maybe the current information that we're looking into. But with LangChain, we can build tools that are calling our APIs, our custom APIs, or looking into our private data that we have on premises. So LangChain enables us to do this using chains and agents. But so when we're talking about chains, we're just talking about our whole process flow on how the user asks a question. The question is then sent through a retrieval tool. A retrieval tool will look into what we call vector databases. Vector database is how we are able to store our data in a language understood by our LLM, which is a mathematical format. So look at it like a database that just stores an array of matrices, but you might find maybe a 3 by 3 matrix is representing the letter dog. So, but it makes it easy for the LLM to go through this vast amount of data quicker than if it is words. So it might be words in Zulu, Shona, Ndebele, Setswana. The REG will still be able to pick up the relevant information because it doesn't depend on the language. It depends on this number system, the vectors that have been stored in our data store. So how LangChain works is that first of all, we have to create, if we had data that in this case, let's say we have a bunch of books from our colleges or from our schools, we would have to create a vector database from these PDFs. It might be doc files, whatever file you might think. It might be images. We can vectorize them and store them in a vector database so that the LLM can ask. How the process goes: we start by loading, we split the data, we embed the data, and we store it in our vector database. And with our vector databases, most of the time they can be offline, they can be online, depending on how or the use case you have. But in this regard, the store will be offline because maybe it might be us vectorizing patient information. So the store can be stored as a small local file that the AI can just go into, or LangChain will just go into there and use it to retrieve the relevant information and passing it to our LLM for the LLM to generate a response. So this is how a RAG is structured per se. It expects a question from the user. It might be, I have a patient in front of me, they have a fever, their temperature is 35 degrees or it's 45 degrees, whatever the question is from the doctor. It then goes through our vector store that we just created with the indexing, splitting, embedding, and storing, and it selects the relevant information. In this illustration, you can see those blue parts. Let's say a question has been sent to the RAG system. What then happens is that the blue parts is more of us demonstrating how we pick the most relevant information. And once that is picked, the data is then passed into our prompt for context. So within our prompt engineering, there are different types of prompts. We have our basic prompts like what is lemon, or how do we make lemon juice? That's our prompt. But when we're working with RAG, at the backside of things, we also have to create a template prompt so that this RAG system understands who it's supposed to serve, what it is supposed to do. So the one that I'm going to demonstrate in this talk is called a reactive agent. And it goes through a thought action process, which is kind of cool to see our RAG going through its thought process, something that we never see. It just does the picking. We don't know how it did it and brings back the data to us. But once we have our prompt set up, what happens is that with our prompt, it then builds this large text file that is then passed to our LLM. So this text file will include the prompt, it will include the information that has been retrieved from our vector database, and it is passed to our LLM. The LLM, in this case, we just need it for reasoning and text generation. So once that data has been sent through, the LLM will then generate the data depending on how we structured our prompt. So this is for Pythonistas. This is basically the packages that you need from LangChain. You need the LangChain core tools. You need the LangChain community. There's what we call the LangChain hub, where there is stuff that is already pre-made for us, where you just pull them. There are prompts that are already pre-made on LangChain hub. You can find some of those prompts on our Hugging Face and other repositories that we have out there, depending on the case scenario that you're trying to solve. And I'm also using a tool from Google that they have with LangChain, so that I'm able to use an LLM from Google in this whole chain flow. So we have the two most important parts of our RAG systems is our chain, question answering chain, and our RAG chain. So with our question answering chain, that's where we join the LLM and the prompt so that they know of each other. The LLM knows of the prompt. The prompt is the directions, who it's supposed to serve, what it's supposed to do. That's how we initiate the question answering chain. Then we'll then create the RAG chain. The RAG chain is the one that does the retrieval from our vector store. And with the, in this case, we pass to the, in our retrieval chain, we pass the retriever and the question answering chain. So it goes back to the flow that we had here, where now the prompt is embedded with the question coming from the user. And that question is then integrated with the relevant information picked from our vector database. And the RAG chain in this regard, the response, if we print RAG chain, it will be the response from the question that was passed on to the RAG chain. So we'll go to our prompts and try to see the difference within our prompts, and we'll see the prompts in action. in this regard, this is a very small prompt where it's just a statement at the backside of the reg to then say, we are instructing it, telling it that it's a doctor's aid that's supposed to help them in clinical medicine diagnosis, patient problems. And the doctor, in this case, we're telling it that the doctor will make the final decision. So it won't come off as if we're replacing doctors. We're not replacing them. We just want to give them those tools that can help them. So this is the most basic one. And the context, you might ask yourself, what is the context? This is how we then join the question from the users into the prompt, because when that context is then created, it's passed on to the LLM, and the LLM does its job of generating the information or generating text that we can understand based on this retrieved information from our vector database or from our tools. In that case, with the tools, you might find it's a tool to search the internet. So if it doesn't find it in the vector database, you can write a tool which uses Google search and it gets results from the internet. They come back, for example, our first result page, there might be like 20 results. It can take all of those 20 results, summarize them, give them back to the user. So in this regard, you can just make your own reg that can just search the internet for you, maybe via WhatsApp without you being actually connected, and maybe just have WhatsApp data bundles. So how this solution will be great for doctors, especially in remote areas, that would find themselves being able to search this vast amount of information on the internet. But because of the prompt we have, it just doesn't go and pick out all the information. You can even direct the repositories or the websites or whatever it might be, university websites where there's theses and things like that. It will just go specific to where you tell it to go to fetch the information for, which means that our reg will not just hallucinate information. We're giving it some sort of direction so that when we give it a question, it gives us an answer that is very relevant to our question. So this is more of like a controlling mechanism where we are able, the power is given back to the developer to control what the reg can do and what it can't do. Because in most cases, we know how you can ask it a question and it just goes the other direction, or it just gets lost in the search. But when we have prompts like this, it is like an assistant which just does one job, not these pre-trained models or the chat GPTs that we work with that are trained on a lot of information, and some of the time they might bring you some not so factual information. So in our prompting, the one that we're seeing now, this is our most basic prompt where it just takes the context. But in this case, we'll be talking about our reactive agents, which go through a thought action process. So what we do with this prompt, when we create this prompt, there is a prompt template that we get from LangChain, and we then define the tool when we have defined the tools in our code. So how we define the tools, it's very simple, just our normal functions, but there is a decorator function that LangChain comes with that you just put on the function, and the RegChain knows that this is a tool which is supposed to be used by the LLM in its process. And within that function, you add a doc string, and that doc string is more information for the LLM to know what the tool is supposed to do, so that when it is going through that thought action process, it picks the right tool based on the question. And also, the other cool thing we can do with our regs is add memory. LangChain also comes with the capability of adding memory to the reg agent. What that means is that when a doctor interacts, maybe they have patient one in front of them, then they ask the reg, and the reg is connected, let's say, to a patient database, but they ask about a certain condition or they prescribe something. With our memory can be attached to a session ID or a user ID, which means whenever the patient one comes back to the doctor, there is still history, or the reg actually knows the history of the chat previously or by the time they visited the doctor. So how we then create our memory, we pass it as context when we're building that whole prompt that we pass to the LLM. So how it stores it is more of in a dictionary where we have the human question, which is the input, and the AI's answer. So it just stores it as a dictionary with human, AI, human, AI. So in the next chat, it just uses it as context for the previous questions. So with that one, what then can help, how it can then help the doctor is that the user is the doctor is our user in this regard. I might get a little bit confused because we use a lot of users all the time. But the user in this regard, because of the history that is in front of them or the reg knowing the history about this patient, it can even help them have insights on the current problem that the patient one is facing because we already have a record and the reg knows about the patient's record. So I'm going to go through a demo. I just hope, I heard that the demo goes somewhere and I just hope it goes well. But the interesting part with this whole show thing, the demo, I just want us to see how the RAG system will get in action, how it does the whole thought process thing. And there we go. Okay, so the interface I used for this, I didn't have much time to build the user interface, so I'll be talking to the bot via our WhatsApp. So I built an API where we can communicate with this RAG system via WhatsApp. So that we see that it's live, let's just test if it is working. Yes, it's working. So that's like a basic prompt where it goes, it just asks, it just tells you, how can I help you today? So with that one, since we're just talking about our prompts and our thought action process, this is how it then goes. Um, in so basically what it did there is that when the question came to our reg, it went through the thought action to ask itself behind the hood, do I really need to use a tool? Then it said no. Then it just goes straight to the final answer where it says, hi there, how can I help you? So if I'm not specific, or even if I ask it things in agriculture, it will tell you I am only trained to work in the health space. But let's give it a shot with tomato farming. Oh, so in, in this case, it did something that I didn't think it would do. It went through a search process on the internet to help us with tomato farming, but the LLM will generate a response. Uh, okay, Twilio didn't allow me. There was a lot of text that was sent back there. Let's give it a retry. Hello. Then it goes through. As you can see with the chat history, it's already passed into the LLM like that. We rerun it, so there's no history there, but we'll see it when we do another prompt. We sent hello, that's the chat history, there was nothing, that was the output. Still same thought process. Let's say, help me find best malaria drugs. Oh, the advantage we have with these things that even if I put the wrong spelling, it'll still figure it out because it uses the vector formatting for the semantic searches. So now we'll go back to our thought process. So it went through the whole thought process here. Do I need to use a tool? Yes. It then used a retriever to check in our vector store. So in this regard, what happened is that I have got a subset of books that I used to create. This is our vector store. I'm using FICE. FICE, you have a lot of other options for creating your vector databases. You can even use your Postgres and have a tool on top of it, which is called PG Vector, where you can do semantic searches in your normal structured database. So in this one, it went in the retriever. The retriever checks in our FICE index. But basically what that means, it started by checking the books that I gave it and looked for relevant malaria information. And it asked itself again, if that answer is so relevant, the answer will be no in the thought process, and it gives back the answer to the user. So if we go back to then check, it then tells us what the best malaria drugs are. We can even go on and say, what are the most okay, let's go cheapest malaria drugs. So again, that is quite fast. Then based on the information, I have some relatively inexpensive malaria drugs include. So it then went with this one. What it did is also it didn't go to search, but we can also have it search the internet like what doctors would you recommend in Pretoria? So this is so it might be questions from the doctors to help them with research. So depending on what question you send through, you train the LLM on, or if you have pre-tuned it. Why we use RAG actually is so that fine-tuning is expensive. So with RAG, if we can build these tools around our AI system or our LLM, it has less costs in the whole process than fine tuning. We don't have, it's actually hard to structure data, clean up the data so that we can train our LLM. So with this one, if you go look up, all these doctors are actual real doctors that are there. It went to search the internet using EXA. Like in this one, it then says final answer based on my search. So it searched the internet. These are results from the first page, and I'm only selecting the first 5 results from the internet search, and it was passed on to the LLM. And the LLM, as you can see, the data looks a little bit dirty for someone to get it or understand, but that's where the LLM comes into play, where it's all summarized and it is formatted in a readable manner. So then there's a question of how do we then optimize this? How do we then, because with tokens, the amount of tokens we send to an LLM, let's say we're using an LLM from OpenAI, there's costs to sending through tokens and receiving tokens. There is a tool that comes from LangChain that is called Langsmith. So Langsmith enables us to trace all the steps the LLM took or all the steps the RAG took to come out to an answer. And we can even check the costs of the tokens that we sent, where there were delays, and we will then optimize like that. In terms of the data, if maybe we didn't train it or we didn't feed it with the right data, which means we can add more data to it, so it becomes more precise and more factual in this one. So I'll open the last one where we're searching for doctors on the internet. So this is the whole process as it was doing it. As you can see here, the first step that it did, it passed the history, the previous history that we had. The human, hello, AI, hello, how can I assist the human? Also the AI, human, AI. So that's the history. It has been passed on to this question. So if there's something in the history, instead of it going to the internet to search, if it was already in the history, it might just use the history as the context and then generate the answer as quickly as it can. So with all these processes, we also have times that it took to do that. So in this case, the agent gets executed there. It got some history there, but the agent starts to work from this part. Then when the agent is initiated, the prompt template that we created is also embedded into the chain, into our reg chain there. And so basically there's a part where there's a chain that I showed where we have a part where we pass in the prompt and the LLM. We're using the Google Gemini LLM in this case, the 2.0 Flash. It was a little bit less cost than the Pro one, and it's still doing pretty fine if you look at the speeds of our responses. So here, when it did the decision in the thought process, it then decided to use the search. And when it did the search, it took 4 seconds to actually do the whole search. This is how the search was, where the data came from. So we can optimize this lang chain helps us to optimize our reg so that it's very precise. And in the medical industry, we wouldn't want our reg to be selecting random data or just using its pre-trained data that is out there. So then this will be the whole sequence. And at the end of it all, the prompt is then attached again because the last thought or the text generation must be based on what we told the LLM it's supposed to do and who it's supposed to serve. So Basically, this is our regs and our long chain agents, and there is more that we can do to this. For example, people that already have existing data, like I have said. Let's go through some of the code, and so that we understand what's really going on. Here in this case, we have our vector database that we are creating the vector database here. We have our function to go through all the PDF files in a directory called books, extract all the text from that. And there's a process which we call chunking. In this case, with the chunking, we like to put our data in small chunks so that when our retriever is selecting information, it just doesn't select the whole book, because it can. It'll go and select the relevant chunks and then passes it back to the LLM in that flow. So this is how we create it. And this script, we just run it as it is. It's not part of the reg. It's just a script to create the FICE index, which is our vector database. Then we'll go to the prompt that we're actually using in this case. This is how the prompt is. I tell the LLM, you can give it a name here. So let's say we give it a name here to then say, your name is Bob. When we send that message, hello, it will tell you, hey, I'm Bob, I'm a medical health assistant. So the reg reacts based on the prompt that you set up at the back end of things. So here I'm just explaining to the reg what it's supposed to do, the steps and all the processes that it's supposed to help the doctors with. Then I empower it with the tools that I've created to do the internet searches, to do the database searches, to whatever you think of. It might be video searches, but in this one, the cool thing that I found with this one is that I had built some models, but in this one, they're not health models. I didn't get that much data to train, let's say, one model where we can pass in X-ray pictures, and our models, our Keras model is able to give us the confidence of maybe if there is like lung cancer, we get the confidence and the disease that has been detected. Since it's just two things, our confidence, doctors won't understand that. So if you have it in this chain, it's sent back to the LLM, and the LLM then generates text that will give the doctor more insight about that image based on the result coming from our custom models. So when we're building tools, there's no limit to building the tools. You can build tools to generate reports. You can build tools to generate our dashboards. In this case, you just need to chat with can I have statistics of the number of patients that we've worked with, or patients with TB, patients who are suffering from diabetes. It can just do it, go through this data that you have created, use this data that is existing in your databases, is then fetched into the LLM. The LLM will use a tool. If it's a tool, to use matplotlib to lay out how everything is set up graphically, then your tool will just be picked. So here, that's where we give it power of having these tools that it must select. And these 4 steps is our thought action process, which it does. And when it needs to use a tool, it says yes. It then picks a tool. How it picks a tool? Through our doc string. So let me go to the index of the reg itself, so we see how tools are structured. So with this one, I've got a tool. This is a basic search tool that searches the internet. I'm using what we call EXA. It's a search engine that is powered by LLMs. So also how it searches the internet is quite brilliant. So in this case, that's why I used it instead of Google. You can use Google or whatever, or Duck. I think there's other search engines out there. The tools, you can build the tools in whatever way you like. Like in this case, I'm even selecting the number of results from the internet search that it must use. And also the decorator at 2, it's not really a decorator, because the decorators come within the decorators that we know, they come from Python, the language itself. This is more of a function that has already been built by LangChain, that when we just add it on top of our function, it is then created into this tool. So we don't really need to know how those tools are created or create these tools from scratch. We just have to apply our logic at the decorator, and the LLM can do what you want. And this other tool is our retrieval tool. which checks in our vector database. We have a very special key that we always use, which is the search quarks, the K. The K value determines how many chunks are brought back to the user. But the most relevant chunk is the first chunk in the results that have been retrieved from our vector database. So in this case, I put 1 so that I get the most relevant information. You can put 2, you can put 4, you can put 5, depending on the data that you fed into your vector database. If you know it's all factual data, rather maybe get more chunks, and the LLM will generate insights that are better than it picking on one chunk. But one chunk is the best according to my experiments playing around with them, because I was making chunks out of 1,000 tokens. And usually when you are chunking, you must make sure you understand the context window of the LLM that you are using, because some context windows are small, so they'll take lesser tokens, and some are big. In this case, that's why I'm using Gemini. It has a big token window, so I can pass images, I can pass videos to it, and also pass text. And with this one, it was just me demonstration on showing you how you can just have tools. If you pass a city to this function, which means our LLM is able to tell the weather in whatever city that you pass to it. You can ask it, what is the weather in Cape Town today? It'll bring you the most relevant information or the current weather data, because it's calling an API, and it will then generate the text or make it in a structured way that humans would fully understand. So then we have our tools array. In our tools array, the tools array is what we pass to our LLM to use. In this case, this is our agent. We pass the LLM model, the tools, and the prompt. That's then how the magic happens. And the agent executor is just running the inference, or whereby we are generating this text based on the findings from the vector database, the findings from the tools that we're searching the internet, or our structured databases. So I think that will be it for now. This code, I'll put a link so that you guys can continue playing around with it, and we'll be able to see what things that the community can build, or actually looking at the red tapes that are usually out there, or when it comes to health data. I believe with so much talented people in this place, where they have access to the real data, and they can actually just attach this agent to the data that you have as a tool and start seeing what it can do. And yeah, it's amazing what these LLMs can do, is all I can say. Thank you. If there is any questions, I think I'll be happy to take on the questions.